Welcome to the B Network. Here we are at Pennwood Middle School in Lower Mayfield Township, Pennsylvania. Today we're going to take a peek into the future, hopefully. We're meeting with a teacher named Pete Swanson, who's being proactive in the fight against fossil fuels. He's taken a group of 8th grade students and is teaching them how to build their own wind generators. Now, if you're one of those people that doesn't mind paying their electric bill, doesn't think that gas prices are out of hand, and you just think the world is all cushy and cozy, well then this isn't going to interest you. But if you can imagine a world without an electricity bill, you're going to want to see what we got to show you today. Let's go. So here we are with Pete Swanson and Rob Wehrs. These guys are teachers here at Pennwood Middle School in Lower Mayfield, and they're being proactive. They are teaching kids how to make wind generators. How you doing, Pete?
Good today.
Rob, how are you?
Sweet.
You guys going to show us what you got here? Like this right here? Power in your house? Someday, maybe?
What we have here are some student-led projects where the students learn a little bit about wind power, where it comes from, how it generates electricity, and they learn a little about energy and where does electricity come from. These are just examples of propeller blade designs that they did, where they have to design a blade that will generate hopefully the most electricity possible. They also learn a little bit about efficiency and the most efficient design, and then they test their blades using obviously an old box fan that generates the wind force in here, so it's a controlled environment. And the goal is obviously to get the most power out of your wind blade with the set wind speed.
You can see right here.
So
They got a meter.
I'll turn this on and you can watch the meter go up as the blade starts to spin. So that gives the students a visual output of what they're outputting.
So to scale, how big would you have to make one of these in order to, say, power a 2-bedroom house?
2-bedroom house, you need about a 100-foot span, 50 foot on each blade.
Okay.
So, and then it obviously gets sequentially bigger as you do a whole city or you do a whole village, so it depends on the size.
And what made you come up with this idea to teach these kids this?
The idea really originated with Pennsbury's initiative about a year ago on energy conservation. They did a big initiative where they had a company come out and audit all of our buildings to determine how we can cut down our power consumption, which triggered the idea of what can I do as a teacher to kind of raise a level of awareness with students about where does our energy come from and how to conserve. So it kind of tied in with that, and it tied in with some science standards related to electricity and DC voltage. So it's kind of a good marriage of the two. So I thought that was a good time to kind of springboard and jump right into this unit.
Here we have all the different parts that we use. This is basically just PVC, which is used in common household plumbing. So it's mocked up to make a stand with just a T at the end here, which holds our motor. This is actually just a regular DC motor, which if you hooked voltage up to it, it would spin. Just like a regular motor, if you spin this, it'll actually create electricity. This thing goes into this holder here, which holds our motor in place. On the motor, we mount one of these little hubs. It just has a small hole in the middle, which goes on the shaft of that motor. These hubs are actually pretty cool little pieces. When you take this screw out, you can open this up and mount pretty much anything you want it to mount in there that's about a 1/4 inch in diameter. You could use a dowel. We also have some connects that we use in there, so you can connect connects into there. Basically anything that's a 1/4 inch in diameter will fit in there. We also, with some of these pinwheels, actually just put the pinwheel right through the center screw here as well. So there's a lot of different ways that you can hook things up to this hub. And this connects onto the front of those motors like that. And then from there, the students can design their blades, which they attach to the hub, and basically hook it up to our voltmeter, which is the last piece of the puzzle here. This is just a standard voltmeter. You can hook a positive and negative voltage up to these 2 wires, and it'll basically read and show you how much voltage you're creating there. Oddly enough, this small one right here seems to create the most voltage out of all of the designs we've had so far. I think that's probably due to the fact that this blade design does not deflect very much, whereas these larger designs, as the wind blows on them, because they're only paper or oak tag, the blades themselves actually move backward and become less efficient. They don't cup as much or catch as much of the wind. So that's my theory on why this one actually creates the most voltage. Now realize too that this is only giving us a reading of how much voltage it's creating. So if there was a load on this, if it was actually powering a motor, you might find that these bigger ones become more efficient. This is just showing us just the voltage of how much it's potentially creating, not how much work it's actually doing. So that's why I think the smaller one's working better.
And what kind of reactions are you getting from the kids? Are they excited about what they're learning?
I think they're very excited about what they're learning. I think what's great about the unit is you get a direct feedback right there with that meter. The other neat thing about it is I have them do, like I said, calculations on efficiency where they learn about variables, like air density is a big variable and how good your blade will do. So like today, it may read about 3.5, and if there's a different change in the weather, we look it up live on the net, determine our sea level and the current air density, and it may change. So there's a fluctuation in the design, which is pretty neat. So they learn about a lot of the variables that go into wind power, so I think it's neat. And they seem very excited. They take their blades on and off, and they must change the design at least 10 times.
They love changing it,
Yeah.
so I mean that just shows that they want to do it. They can't wait to come over here, try it, see their measurements, see how good they did.
But the biggest factor that they learn about, too, is for a residential house, is you really need to be high up so there isn't the trees to slow down the wind. So it'd be hard for residential to get really true efficiency like you see in the fields where they're open. But they do make residential models that go on your roof that can generate a fair amount of power. So, and the students also learn, which is kind of neat, I show them a map of the U.S., and they learn where the most wind is within the United States.
Okay.
So Jersey and PA are average. Midwest, like Minnesota and areas, are huge for wind power. So it really
Tornado
depends.
Alley.
Yeah, exactly.
Tornado Alley.
So
Get your wind generator out in the Tornado Alley.
That'd be a good spot. So it's neat for them to realize that there is different areas that have more wind.
Nice. Well, thank you very much, guys.
Yeah, thank you. It's good talking to you.
Hey, this is what we need out there. People doing things. People making the difference, passing it on to the next generation.